So reactant in zeroth order depletes to 0.03 moles from 0.46 moles in 6.5 hours. Find the half-life of this reaction. So this problem will be divided into two parts, and we'll use this first equation. So AT equals negative KT plus A initial. This is the overall zeroth order formula. So we know for sure that AT is the final time. So it's going to be 0.03. What AO is meaning to the initial time. Or the starting time. So basically what we're going to do is plug those values in first. But actually first what we need to do is change 0.65 hours into seconds. So we'll do this by just setting up a little conversion formula. So I'm going to do 6.5 hours times 60 minutes over 1 hour times 60 seconds over 1 minute. And we'll get, by plugging everything into the calculator, 2,340 seconds. Oops, that looks like a bad 5, but it's an S for seconds. From that, we know everything, all the values that we need, so we can just plug everything back into the original formula. So AT, again, was the final amount, so it's going to be 0.03 moles equals negative K the time is 2,340 seconds, like we just figured out, plus AO, the starting time, which was 0.46 moles. By plugging everything into a calculator, we're able to realize that K equals 1.84 times 10 to the negative 4. So now that's just figuring out one part. We figure out what K is equal to. So the only reason we did this was because we need to plug K into the overall general formula for the half-life of zero order. So I'm just going to erase all this. And I'm going to actually now start to set up my final formula for the half-life in zero order. Sorry. So the half-life in their order is going to be equal to AO over 2K. So AO, like we said, was the beginning initial time. So it's going to be 0.46 over 2 over the value that we got for K, which was 1.84 times 10 to the negative 4. By doing this, we get 1,250 seconds. So the half-life that it took 4.03 moles from 0.46 hours is going to be 1,250 seconds.